In this section, we are going to talk about complex numbers. Okay, so remember that the square root of 4 equals to 2 because 2 times 2 equals to 4. So the root of 4 is 2. Why? Because 2 times 2 equals to 4. But what if we want to find the square root of negative 4? So in other words, which number multiplied by itself will give you a negative 4? Okay, well let's check. Well, we know that 2 times 2 doesn't work because that's equal to positive 4. Well, what about negative 2 times negative 2? That's also equal to positive 4. Okay, so now we can say, well, negative 2 times 2 is equal to negative 4, but that's not the same number. So for something to be a root of 4, you have to have the same number multiplied twice or by itself to give you 4. But in this case, negative 2 and 2, it's not the same number. So the root of 4, the root of negative 4, it doesn't exist because no number multiplied by itself will give you negative 4. That's the closest you get, but that's not the same number. So negative 4, square root of that doesn't exist because negative 4 doesn't have a square root. So since negative 1 does not exist in the real number system, so just like negative 4, if you say negative 1, that's equal to what times what? Which two numbers multiplied by, or which number multiplied by itself will give you negative 1? Can't do that. 1 times 1 is 1. Negative 1 times negative 1 is positive 1, so that doesn't work. The closest we can get is we can say negative 1 times positive 1 is negative 1, but that's not the same number. So the square root of negative 1, it doesn't exist. So since the square root of negative 1 doesn't exist in the real number system, this is an imaginary number. Square root of negative 1 is an imaginary number since it doesn't exist in the real number system. And square root of negative 1, this is written as I. I is the imaginary number. Okay, now, since I is equal to square root of negative 1, we can say that I squared is equal to negative 1. This is important. Because if I is square root of negative 1 and you square the left side to get I squared, you got to square the right side. The square root and the square cancel each other out. We're left with negative 1. So I squared is equal to negative 1. Okay? Now, a complex number is in the form of a plus bi, where a is the real part, and bi, that's the imaginary part. Okay, so you have a complex number, a plus bi. A is the real part, and bi is the imaginary part. So what are we going to do with complex numbers? Well, for one, we're going to start simplifying them. So if you look at your media notes, your first example is the square root of negative 16. Okay, so here's what we do. We break up the negative 16 into the real part, which is square root of 16, and the imaginary part, which is square root of negative 1. Okay, so all I'm doing is I'm rewriting 16 as 16 times negative 1, which we can do. So how does that help us? Well, square root of 16 is equal to 4, and we know by definition that the square root of negative 1, that's equal to I. So square root of negative 16, that equals to 4i. 16 is the real part, negative 1 is the imaginary part, that's equal to 4i. If you want a little shortcut, you can do this. Every time you see the square root of a negative number, you can just take out the negative and write that outside as an I. It's a little shortcut. So if I were to do square root of negative 25, I would just say, that's an imaginary number, so that's going to come out, become an I. Rad 25 is 5, so this will give me 5i. Okay, it's a little shortcut. If you don't like that shortcut, it's fine. You can break it up like this, and it'll give you the same thing, which is 4i. Okay? Next example. Let's take the square root of negative 54. So again, if you want the shortcut, you can do this. You can say this equals to I times the square root of 54. If you don't want the shortcut, no worries. You can break this up as square root of 54 times square root of negative 1. Either way, we have to simplify the square root of 54. So you got to think about it like this. how can I rewrite 54 so that one of the numbers is a perfect square and one of them is not? So we can rewrite 54 as 9 times 6. How does that help us? 9 is a perfect square. Square root of 9 is equal to 3. So this will give us 3 rad 6. And then rad negative 1, that's equal to I. Now if you multiply this, you got 3 rad 6 times I. The 3 and the I are going to multiply since they're both outside the square root. And you will get 3i times the square root of 6. You take the shortcut, you get I times rad 54. Rad 54 once again is 3 rad 6, so this will give us 3i times the square root of 6. Either way, you get the exact same thing. Okay, so this is how you simplify a complex number. Now we're going to do some operations. We're going to add, subtract, multiply, and divide. Okay, so let's first start off by adding complex numbers. We have our first example, which says you got negative 10 minus 6i plus negative 12 plus 4i. Okay, notice there's a plus sign in between. That means we are adding the two terms. So if I add negative 10 plus negative 12, that gives me negative 22. Notice I'm adding the real part. If I add the imaginary part, you got negative 6 plus 4i, that'll give me a negative 2i. Every complex number has to be written in this form. The real part comes first, the imaginary part comes second. The next example, we have negative 10 minus 6i, so it's the same problem. We've got negative 10 minus 6i minus negative 12 plus 4i. So instead of adding, we're now going to be subtracting the two terms. So how do things change? If you have a plus sign, you're simply combining like terms. If you have a minus sign, we're subtracting. So essentially what's happening is you're doing negative 10 minus negative 12 and negative 6i minus positive 4i. So there are a couple of ways you can do this. You can pick your favorite way. I'm going to show you both ways. So this is method 1. Okay, method 1, you can rewrite the whole thing. So you can write negative 10 minus 6i. You can take the negative and you distribute that. So this will give you a positive 12, and a negative times positive is negative 4i. You combine in like terms. Negative 10 plus 12 is 2. Negative 6 minus 4 is going to be negative 10i. Okay, that's one way of doing this. So in the first method, you distribute the negative, rewrite the whole thing, combine like terms. The second method, method 2, and it doesn't matter to me which method you use. In method 2, you split this up as negative 10 minus negative 12. So we're subtracting, right? So we subtract negative 10 minus negative 12. And then we have negative 6i minus 4i. And you got to be careful. When you split this up, this is like saying negative 10 plus negative 6i. So that's why there's a plus sign in the middle. Okay? The minus sign is actually a negative sign. It belongs to the 6i. So in between those, there's a plus sign, which is why there's a plus sign here. So you got negative 10 minus negative 12. The two negatives turn into a positive. That will give me 2. Negative 6 minus 4i is going to give me a negative 10i. So you got 2 plus negative 10i, which you can rewrite as 2 minus 10i. Most people prefer the first method. Most people find that easier, but if you're in the minority that finds method 2 easier, by all means use it, but don't forget, you put a plus sign in between the two terms. But I would recommend the first method. It's cleaner, it's easier. You distribute the negative, write all the terms, and combine them. Okay, so we did adding, we did subtracting. Now let's do multiplication and division. Okay, so multiplication. We have negative 10 minus 6i. And we're going to multiply this by negative 12 plus 4i. Okay, how do we know it's multiplication? Because there's no operation in between. There's a plus sign, there's a minus sign. If you just have two parentheses that are side to side without an operation, it's multiplication. Okay, so let's FOIL this. We have negative 10 times negative 12, that's positive 120. We have negative 10 times 4i, that's going to be negative 40i. Then you have negative 6i times negative 12. Negative times negative is positive 72i. And you have negative 6i times a positive 4i, which is a negative 24i squared. Okay? So you FOILed. Now let's combine our like terms. So far, that's an I squared, so that's not a like term with the i's. But these are like terms. So we can say this is 120. Negative 40 plus 72, that'll give me 32i minus 24i squared. If you leave your answer like this, it is incorrect. So why is it incorrect? Because remember, we learned earlier that I squared, that actually equals to negative 1. So when you see an I squared, you're going to replace that with a negative 1. So we got 120 plus 32i minus 24 times negative 1. The I squared gets replaced by negative 1. That makes it 120 plus 32i plus 24. And if I combine my like terms, so 120 plus 24, this will give me 144 plus 32i. Make sure you write the real part first and the imaginary part second to put it in the standard form of a complex number. Okay, so that takes care of multiplication. Now the last thing we're doing is division. All right, so in division, here's what we have. We have negative 10 minus 6i, and we are dividing this by negative 12 plus 4i. All right, what do we do here? So, well, can I split this up as negative 10 over negative 12 minus 6i over 4i? Can I do this? Okay, if you're zoning out, pay attention, common mistake. Absolutely not. Okay, we cannot do this. This is very, 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 very incorrect. So why is it incorrect? Because remember that if you have a minus sign or a plus sign, this becomes like one term. And we can't ever separate these into two different terms. So the denominator cannot get separated into two different terms because it's joined by the plus sign. Okay, so this cannot happen. So what do we do instead? So you use something called, in this case, something called a conjugate. And we'll talk about this a little bit more in class. Okay, so what is a conjugate? A conjugate is the same two terms with the sign changed. So instead of negative 12 plus 4i, we are going to multiply this by the conjugate of negative 12 plus 4i. And I'm going to show you guys why we use that, which is going to be negative 12 minus 4i. Okay, and we're going to multiply this by negative 12 minus 4i. We don't want to leave an I on the denominator, so to get rid of it, we're going to multiply it by the conjugate. Okay? So, let's simplify this. So now we're FOILing again. On the numerator, we have negative 10 times negative 12. That's going to be positive 120. You have negative 10 times a negative 4i. It's going to give me a positive 40i. I have negative 6i times negative 12, which is a positive 72i. And I have a negative 6i times a negative 4i, which is a positive 24i squared. Now before I deal with the denominator, I'm just going to simplify the numerator. So remember that I squared is equal to negative 1. So this is actually going to be 24 times negative 1, because I squared is negative 1. That's negative 24. So I have 120, and then I have a minus 24. If I take 120 minus 24, that'll give me 96. Then I have 40i plus 72i, which is going to be 112i. Okay, that's the numerator. Now let's deal with the denominator. Denominator, we have a negative 12 times a negative 12. That's a positive 144. Then I have a negative 12 times a negative 4i. A negative times a negative is a positive, so positive 48i. Then you have a 4i times a negative 12, which is a negative 48i. And then you have a negative 4i times a negative 4i, which gives you a negative 16i squared. Here's why the conjugate works. Because it's the same numbers with the sign change, you get a positive 48i and a negative 48i, which you can now cancel out. And because you can cancel it out, the i's are now gone. Well, we have an I squared, but remember that equals to negative 1. So this is actually a negative 16 times negative 1, which is a positive 16. So we got 144, negative 16 times negative 1, that's a positive 16 essentially. This thing here is a positive 16. So 144 plus 16, that's going to give us a 160. Okay, so on the numerator, we had 24i squared, that's 24 times negative 1, which is negative 24, so we did 120 minus 24, that's 96. On the denominator, we had 144, negative times negative is positive 16, that's why we got a 160. Okay, now are we done? Not quite, we have to simplify. At this point, because the 160 is just one term, now we can split up the numerator into two separate terms. We can split this up as 96 over 160 plus 112 over 160i. Okay, so if you reduce this, you got to figure out which term goes into 96 and 160. I believe 32 does. 32 goes into 196 3 times, and 36 goes into 160 5 times. So this becomes 3/5. What about the 112 and the 160? 16 goes into both of those. You can reduce it by 16. 16 goes into 112 7 times. 16 goes into 160 10 times. So my final answer is going to be 3/5, that's the real part, plus 7 over 10i, which is the imaginary part. Okay, on the back of your media notes, you guys will see two examples. It says solve using the quadratic formula, but now it says find all solutions, real and imaginary. So these two problems we're going to do in class. If you want to try them out on your own and you can check your answer once we go over them, that's totally fine. If not, you can wait till we go over these in class. And come prepared with questions.